Okay, Year 11, welcome to your video tutorial. Today we are going to look at the binary, decimal and hexadecimal systems and how to convert in between them. If you want to pause this and actually read it, you can. The three systems that we are going to look at today are binary, which is base 2, decimal, which is base 10, and hexadecimal, which is base 16. So basically, as we established at the start of the year, computers cannot understand numbers. They're electronic circuits. They have transistors. They know on and off. I represent these two states, on, off, 1 for on, 0 for off, with the binary system. Information gets passed around my electronic circuit in bytes. 8 bits, or 8 ones and zeros, equals a byte. It can get tedious, however, to represent things in binary. So if one byte is made up of 8 bits, so 10110101, for example, so that was 8 zeros and ones, and that's a byte, it gets annoying for people to kind of keep track of. So we have one other system, which is the hexadecimal system, and it is based on the numbers 1 to 9, then A, B, C, D, E, F. So for example, 8 binary digits, so 1 byte, can be represented using just 2 hexadecimal digits. TLDR, we're going to look at 3 systems, binary, decimal and hex. Binary is base 2, decimal is base 10, hex is base 16. This base bit and the base 2 is going to make a lot more sense when we look at how to convert them. Okay, what do you have to do? You have to be able to convert between decimal and binary. So you have to be able to convert the number 92 to binary. You can convert all the way up from 1 to 255 in 1 byte, or using 1, 2, 3, 4, 5, 6, 7, 8 bits. In order to do that, the first thing you need to draw up is this table every single time. When I said binary was base 2, we start at 2 to the power of 0, which is 1, 2 to the power of 1, which is 2, 2 to the power of 2, which is 4, 2 to the power of 3, which is 8, and so on and so forth for 1, 2, 3, 4, 5, 6, 7, 8 bits or 1 byte. Let's look at how we do this. It's real simple. First thing I do is I draw up my table. I work from left to right. Okay, left to right. I start on the left. I have the number 92. I don't have to write 128 underneath 2 to the power of 7 if I know what 2 to the power of 7 is off by heart. I don't. I make mistakes, so I like to put it down. Now, 92. I cannot make 128 is bigger than 92, so I put a 0 in there. Okay, 64 can fit into 92 once. With how many left over? It's like a running tally. 92 minus 64, 2 minus 4 I can't do, 12 minus 4 is 8, 8 minus 6 is 2, so I'm left with 28. Cannot be made up of 32, no, I can put 16 in there. And again, it's a running tally, so 28 minus 16, 8 minus 6 is 2, 2 minus 1 is 1, so I've got 12 left over, which can be made up of 8, which leaves me with 4 left over, which made up of 4, and nothing left over. So it's like a running tally. I start from the left to the right to see if 92 can be made up of 128. It can be made up of 64 and something else. So I can put a 1, I work out the difference, I then use that difference as my running total. So 92, or decimal 92 in binary, is represented by 0, 1, 0, 1, 1, 1, 0, 0. That's my binary, or 1, 2, 3, 4, 5, 6, 7, 8 bits. Cha-ching! Okay, so if you look at 232 by the same regard, this is just another example. So 128, 2 can't do, 2, 12, 4, 2 minus 2 is 0. I've got 104 left over, which can be made up of 64, which hopefully you can all see is I have 40 left over. 40 can be made up of 32, which gives me 8 left over, which means can't be made up of 16. 1 on 8, 0, 0. Okay, always a good idea, always have to draw this table up, okay? Binary to decimal, it's real easy. This is my number. I know I move from left to right, okay? I put my number in, 1, 0, 0, 1, 1, 0, 1, 0. What have I got? I've got 128, so this is reverse engineering, 128 here, 16, okay, because I didn't count the 64 or the 32. I've got 16, I've got 8, and I've got 2. 2 plus 8 is 10, 18, 24. Hope that's right. Jokes, it is. 2, 2, 4, 1 is 5, and 1. So that binary is 154 in decimal. Another example, 1, 1, 1, 0, 1, 1, 0, 0. Always a good idea to have that table pre-drawn up for yourself. In an exam, you will be required to make a table, which is annoying, but you will. 8, 4, 12, 14, 16, 24 again. Weird. 2, 4, 10, 13. Okay, 234. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 1, 0, 1, 1, 0, 0 is 234 in decimal. Okay, here is where it gets a little bit tricky. I stuffed up my number on the PowerPoint, so I've just had to go and erase it and write it again. But binary to hexadecimal is a little bit different. I said it's base 16 because we have 16 possible options in our numbering system. How you work out a hexadecimal number is that you break it down into groups of 4. So 1, 2, 3, 4. And if I'm breaking it down into 4, my table won't have 8 bits. It'll be 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Okay? Because this is a binary number and I'm converting it to hex, I still have to use the binary table. Okay? And I simply go 0, 0, 1, 1. So what number have I got there in decimal? I've got 8, 9, 10, 11, 12. I've got 12. Okay, and if I go along here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this portion of my number would be C. That's how I do it, 4 at a time. So let me show you how you do the whole table. I've already established that this guy in here is C, okay, because I counted 12 down. Now I have to do this guy, 1, 2, 3, 4. And what you'll notice I've actually included in here for you is a number that's not a byte. I've actually included another 1 on the end, and I'll show you why I've done that. Okay, so this number, I'm popping it in here, 0, 1, 0, 1. So for this I have no 8s, a 4, and a 1, so I have 5. And if I go down, 1, 2, 3, 4, 5, I can actually use 5. Okay, so this in here is 5. 5C is a binary digit represented. So I can actually just use, you'll see why it's more easy. Instead of writing 1, 1, 0, 1, 0, 1, 1, 1, 0, 0, I can just write 5C in hex and it's heaps easier. If for some reason you get a binary thing that is bigger than a byte, okay, bigger than a byte, what you can do with this leftover 1, okay, it would be that you would just literally start from. You've got the leftover, and that is simply a 1. It doesn't have 4 digits to follow it, assuming there was 3 digits preceding it. Assuming there was 3 digits preceding it, the 1 would go in there, so it is literally just 1. So this number above is 15C, inclusive of that. Exclusive of that, it's 5C. And that's it, guys. That's converting between binary and decimal, decimal and binary and hex.